we have a battery here, and I would change the battery to 12 volt to be the same with the question, 12 volt. And I have a 2 light bulb, putting them like this, and the switches. And lastly, I just need to connect the battery with the light bulb. I'm all done like this. And the battery here, 2 light bulb, and the wire. Open the circuit, so we can control the circuit with the switches. And I like to add some other tool, an ammeter here to measure the current. Another ammeter down here, measure the current passing through each light bulb there. In a lab, in a school lab, you have an ammeter like this one. The red here, and black, what's it called? Clamp dot, that you need to connect this ammeter in series like this with the light bulb, meaning this is the positive terminal of the battery. I cannot choose the pen here to write on this. Okay, the pen, cannot choose the pen right on it. You can see the mouse here. This end is the positive terminal of the battery. The black end here is a negative terminal. So when you connect a ammeter in series with the light bulb, this end connected to the positive terminal of the battery must be the red end here. Use a red wire, electric wire. Use a red electric wire to indicate the positive terminal. Connect this red terminal of the ammeter to the positive terminal of the battery, and the black terminal here is connected to the light bulb. Similarly, with the ammeter below here, okay, this is the red terminal, this is the black negative terminal, and then when you close it, the battery is a electric pumper pushing electron. So the current in a circuit like this is called parallel circuit. You can see that when we use the same type of light bulb, each light bulb has a resistance of 10 ohms, so 1.2 ampere, current the same. Similarly, when you use a voltmeter, you need to connect the voltmeter in parallel with the circuit. Let me summarize those things. For example, you have a battery represented by this symbol, a long bar and a shorter bar. The long bar is positive terminal, a shorter bar is negative terminal. And then you connect an ammeter here, another light bulb down there, another ammeter here, another switch here, a light bulb, and connect to the ammeter. So when you use an ammeter like this one, we copy that thing. Okay. Or I make the real picture, parallel circuit, 2 lamps, real picture, that connection. For example, like this, 2 switches, and 2 light bulbs. I want to find how to connect the meter also, and the voltmeter. Okay, let's take this one. When you have an ammeter like this, you put it right here. And wait for the image to load on the screen. This is an ammeter. So the red end of this ammeter, you use a red wire, connect to it, and connect to the positive terminal of the battery, and the black end connect to the lamp. Okay. Similarly, another ammeter down here. The red end is connected to the battery. Let me find a light bulb. Just represent this is a light bulb, school lab. In school lab, it can be a little bulb like this or like this, This is a resistor. Later we will learn that thing also. Resistor. This is the ammeter. And the next thing, you need a voltmeter to measure the voltage. Like this one. Take that one. Measure the voltage of the bottom light bulb here. You need to connect in parallel with the circuit. There's no tool here to rotate because the positive terminal here, the red dot, you need to connect to this end. Okay, and the black dot here connected to the positive terminal. So that's the reason why we need to use 2 types of the electric wire, a red and the black wire, to distinguish the positive, and the black represent the negative terminal. So when you use a ohmmeter, you need to connect like this. If you have another ohmmeter, connect up here, put up here to connect the voltage across the 2 ends of another light bulb. Similarly, the red end here is connected here. So here the simulation. We have a voltmeter connect like this to measure the voltage across this battery, this light bulb up here, and it shows 12 volts, exactly the same with the 12 volt battery, meaning the battery will provide all the energy necessary to push electron through this light bulb. And similarly, when you measure the voltage down here of the second light bulb, you also get 12 volt, meaning the two light bulbs will have the same voltage. Okay, two light bulbs will have the same voltage. Okay, this is the theory. Summarize that on the second page here. In a parallel circuit, we have to memorize a few things. Firstly, they have the same voltage and equal to the voltage of the battery. And secondly, if we put another ammeter here, leaving the current to measure the current that is provided by the battery here, what do you see? The current that the battery provides, which is 2.4 amperes, is split into the two currents, 1.2 ampere on the top and 1.2 ampere on the bottom. So this is the total current. That current split evenly for the two light bulbs because they are identical. But if one light bulb is different, now I will reduce the resistance of this light bulb, like 5 ohms. So you see that the currents are different, not the same, because now the light bulbs are different. One has a smaller resistance. The bottom light bulb having the lower resistance, 5 ohms, will have the greater current. And the upper light bulb having greater resistance will have lower current. Okay, because resistance represents the opponents, the ability to slow down the current. Resistance is the opponents, the ability to slow down the electric current. So greater resistance means lower current. But again, with this simulation, if you have a chance later in the school, going to the lab, of course, you will definitely do the experiment like this, measuring the current and the potential difference, meaning the voltage. So you see that the 5 ohms here, 5 times 2.4, will be equal to 10 times 1.2 here. That product, the resistance multiplied with times the current, is equal to the voltage. And the voltage of the two light bulbs is the same, which is 12 volt. So taking 12 volt here, you divide the resistance 10, 12 divide 10, you get 1.2 ampere. 12 volt here for the bottom lamp, taking 12 and divide 5, you get 2.4. Okay, so from this one, the consequence is that V1 is equal to I1 times, let me write that instead of typing. V1 for the upper lamp will be equal to I1, the current passing through the lamp, multiplied with R1, and it will be equal to I2 times R2, so that the voltage is the same. Okay, let me replace this picture by another picture here with the current being different currents. And lastly, the sum of the current total provided by the battery will be equal to I1 plus I2. With total current 3.6, I1 is 1.2 and I2 is 2.4. So the sum is equal to the current provided by the battery. Ampere. Yeah. So this is the summary of the knowledge of the parallel circuit. So the battery will provide the same energy, which is 12 volt here, meaning it provides 12 joule energy to put 1 unit charge through each light bulb. Provide the same energy for each light bulb, but because each light bulb has a different resistance, so the current passing through each light bulbs are different from each other. It is like the same teacher in a school teaching different students, but different students can gain different understanding. And the next thing, series circuit with the same battery here, but now I will change the construction of the light bulb so that they are now not in parallel anymore, but in series. Two light bulbs in series. This is the series circuit, and when we close, the two light bulbs will shine, and the resistance of the two light bulbs is the same in this example, but let me change that also. The second one here, I will reduce the resistance to be 5. Now, their resistance are different, 10 ohms and 5 ohms, for the current to run through the light bulbs and return to the battery, completing a circuit only one way. Therefore, the current is the same, 0.8 ampere here, okay? The same current. And when you measure the voltage, similarly, this red end is connected to the positive terminal of the battery. This black end is on the other side. This is 4 volt. 4 volt, when the voltage of the battery is 12 volt. When you use another voltmeter to measure the voltage between the poles, the terminal of the second light bulb, change the position of the switch so that it's easier to see. Let me put the switch up here, close the switch. Okay, there. So the second light bulb, you have 8 volt. which is different from the 4 volt of the first light bulb. Okay, and what is the special thing? 12 volt battery.
Yeah.
It means the battery provide in total 12 joules of energy to push 1 coulomb charge through the light bulbs. But 4 joules of energy will be lost to push through the first light bulb on the right here, and then 8 joule energy to push through the second light bulb, because the second light bulb here has a higher resistance. So it requires more work, more energy to push the electron through the second light bulb, having greater resistance. So let me summarize that. So in a series circuit like this is the same, as there is only one direction. Secondly, the voltage V of the battery equal to V1 plus V2. 12 volt supplied by the battery equal to 4 volt through the first light bulb and 8 volt for second light bulb. Okay, the part battery use 12 joule, provide 12 joules of energy, and among that, in which 4 joule is spent on the left light bulb, meaning of the voltage. I cannot move with these text. Make this one smaller. There, the summary. Here the battery provides 12 volt, but the 2 light bulbs are connected in parallel like this. They will draw the power the battery much faster. It's like you are using a lot of electric devices at the same time in your house right now. Air conditioning, light bulbs, fan, computer, etc. Many devices running at the same time. So consuming a lot of electricity, more power. You see that the current here 3.6 ampere. Power of the bottom light bulb will be greater, twice the power of the first light bulb. But the sum will be the total power, the total energy that the light bulb consumes from the battery in 1 second, because we are talking about power in 1 second. Meaning when you connect in series like this, it will consume electricity faster, and you have to pay more money than connecting in series like this. It will consume less energy, but the light bulb will shine weaker, not as strong as the light bulb here. You see the yellow, like the light rays. 1.2 ampere stronger, brightness, greater brightness. 2.4 ampere even greater power, greater brightness. But here only 0.8 ampere, even though the battery is the same, 12 volt. So connecting the light bulb in series like this, it will consume less power, but therefore they operate weaker. In summary, connecting the devices in parallel increases the power, increases the total current, and consume power more money. Connecting them in series, devices in series, lowers, result in lower current, also lower power. Okay, I'd like you to take note about this thing because it's very important, rather than just looking at the online file. This is a link to the board, so next time I can put some question on here, the board, and if you have a Apple Pencil, you can write your solution on the board here. So return to this question 4, you do. So please write the solution of this question 4 at page 5.
Do I need to join the call in my iPad?
Yeah, you need to install the app Jamboard. It takes only less than a minute to install it, Yeah, find Google Jamboard.
How do I send this link to myself? Oh.
After installing, I think you just need to click on the link. It will directly open in the app.
I got it. Oh no, I have to download Jamboard. I need 2 minutes.
Calculate the 2 lamps are connected in series, in parallel. Calculate the current separately for each light bulb, which is I1 for the upper lamp. It is the voltage of the battery, which is 12 volt, right? 12 volts. Divided by the resistance 6 ohm, and therefore you have 2 ampere. Similarly, second current.
Wait, how did you get 12 volts?
It is given in the part A of the question.
Oh, really? Oops.
Yeah. Let me take the screenshot of part A again. Yeah, given here. So similarly, the current passing through the second light bulb is also 2 amperes.
Yes.
Please continue writing I2 equal, and then the total current is the sum of I1 and I2.
One of these lamps has a resistance of 6 ohms. Oh no, resistance of 6 ohms. I2 is the total?
I2 is the current through the bottom, the lower lamp, the second lamp.
Oh, is it the same?
Yeah, the same, because they are the same light bulb.
Yeah, okay.
The diagram. So I2 is also 2 amperes, yeah, and therefore the total current provided by the battery is 2 plus 2.
Yeah.
2 plus 2, which is 4
Four.
amperes.
Okay.
The next one, calculate the power. The total power provided by the battery. You just
Power.
need to use the formula P equal V
Times okay. Equals 12.
V times
I. I is the current for
Yes, which is 4.
48. Power Watson.
Yeah, 48. Got it. Very good. Question C. Next page. Move to the page 7, huh? Yeah, I should have done this long time ago, like using the Jamboard here, because you can write better than the Kami, huh?
Yeah, it's okay.
Power of the other lamp. So this other lamp in question 4C here has nothing to do with the two previous lamps. This is an entirely different question. Just use the information here, 36 watt and 20 hours. Energy, how do you calculate that? Power, and so energy is what? Power multiplied with time. Yeah, so you need to convert that 20 hours into seconds, and then multiply that number of seconds with the 36 watt, the power, and you get the answer, energy. Let's do that. Calculate, convert 20 hours into second.
20 times 60.
60 times 60, yes, beautiful.
And then energy power is 36.
Yeah, and write that in scientific notation.
Yeah.